So hi guys, welcome back to Flame Wall Explains. In today's video, we are going to see about all the types of numbers there are. So first we are starting with natural numbers. Natural numbers are positive integers used for counting, beginning with 1 and extending infinitely. For example 1, 2, 3, 4 and so on. They do not include fractions, decimals or zero, although some definition in fields like computer science and set theory may include zero. Natural numbers are also known as counting numbers. Next we are going to see about whole numbers. Whole numbers are the set of all positive integers, including 0, represented by the set 0, 1, 2, 3 and so on. They do not include negative numbers, fractions or decimals and are used for counting and measurement. Next we are going to see about integer numbers. Integer numbers are whole numbers that can be positive, negative or zero and do not have any fractional or decimal parts. Examples include -3, -2, -1, 0, 1, 2, 3 and so on. Next we are going to see about rational numbers. Rational numbers are any numbers that can be expressed as a simple fraction p by q, where p and q are integers and q is not equal to 0. This includes all integers like 5, which is 5 by 1, fractions like 1 by 2, terminating decimals like 0.25 and repeating decimals like 0.33333, so on. Next we are going to see about irrational numbers. Irrational numbers are real numbers that cannot be expressed as a simple fraction or two integers p by q. Their decimal representation is non-terminating and non-repeating, meaning the digits go forever without a repeating pattern. Examples include pi, the number e, and square roots of non-perfect squares such as square root of 2 and square root of 13. Next we are going to see about real numbers. Real numbers are any numbers that can be placed on the number line, encompassing both rational, integer, fractional and decimal, and irrational numbers, pi and square root 2. They include positive and negative values and are used to measure continuous quantities like length and temperature. Next we are going to see about imaginary numbers. Imaginary numbers are that when squared produce a negative result, defined by an imaginary unit I, where I squared is equal to -1. They are used to find squares of negative numbers and are essential for solving certain quadratic equations. Next we are going to see about complex numbers. Complex numbers are a combination of real numbers and imaginary numbers expressed as a plus bi, where a is the real part and bi is the imaginary part and I is the imaginary unit, which is equal to I square root of 1. Let's just leave that. They are used to represent a wide range of mathematical and physical phenomena, for simple algebraic operations to advanced applications in physics and engineering. Next we are going to see about algebraic numbers. An algebraic number is a number that is a root of a non-zero polynomial with one variable or integer or equivalently rational coefficients. For example, the golden ratio is an algebraic number because it is the root of the polynomial x squared minus x minus 1. Another example is a solution of the equation x squared minus x minus 1 is equal to 0, and the complex number 1 plus I is algebraic because it is the root of the polynomial x to the power 4 plus 4. Algebraic numbers include all integers, rational numbers, and nth root of integers. Next we are going to see about transcendental numbers. A transcendental number is a real or complex number that is not algebraic. The best known transcendental numbers are pi and e. The quality of a big number being transcendental is called transcendentance.
Quaternion, Quaternion, Quaternion.
Next, we are going to see about Quaternion number system. The Quaternion number system extends the complex numbers and applied to mechanics in three-dimensional space. Quaternions are not quite a field because it is general. Multiplication of quaternions is not commutative. Quaternions provide a definition of the quotient of two vectors in three-dimensional space. Quaternions are generally represented in the form a plus bi plus cj plus dk, where the coefficients a, b, c and d are real numbers and I, j and k are basis vectors or basis elements. Next, we are going to see about octonial number system. Octonions are an 8-dimensional, non-associative, non-commutative number system that extends complex number and quaternion numbers. Each octonion is a combination of one real and 7 imaginary parts, where each 7 imaginary units squares to -1. Unlike the more familiar complex number and quaternions, the order of multiplication matters, but they satisfy a weaker form of associativity called alternativity. They have applications in areas like string theory and theoretical physics. Thank you for coming this far into the video, guys. If you like this video, like, share, comment, and hope this was useful to you. Now that's all. Signing off, Flame Wall.